Hi there, welcome to my course. In this lecture you will learn about the XSS Discovery Toolkit Part 1. Barb. The modern browser is designed for speed and efficiency, which means web application security assessment is a painful task because probing a web application requires in-depth analysis. Generally, to test an application, you want to slow down the transmission of data to and from the server to a snail's pace so you can read and modify the transmitted data, hence the proxy. In the early days of security, proxies were capable of slowing down the connection in only the outbound direction, and as such a user could only alter the information being transferred to the server. However, that is only part of the equation when analyzing a web application. Sometimes it greatly behooves you to be able to modify the incoming data. For example, you might want to modify a cookie so that it does not use HTTP only, or remove a JavaScript function. Sometimes you just want a bidirectional microscopic view into every request your browser is making. And then there was Burp Proxy. Burp Proxy is a part of a suite of Java tools called Burp Suite that allow for web application penetration, but for the purpose of only one function is particularly useful, and that is the proxy. To get started, you need the Java runtime environment installed, which you can get from java.com's website. Once that is installed, you modify your proxy settings in your browser to use localhost or 127.0.01 at port 8080. This figure shows the Firefox connection settings dialog. This figure shows Burp Suite main window. Once this is done, you can launch Burp Proxy, which will show you a blank screen. The intercept and options windows are the most important ones that we will be focused on. First, let's configure Burp Proxy to watch both inbound and outbound requests. Under Options, uncheck Resource Type Restrictions. Turn on Interception of Server Responses and uncheck Text as a content type. This will show you all of the data to and from every server you connect to. This figure shows the Burp Suite proxy options configuration screen. Once this has been configured, you should be able to surf and see any data being transferred to and from the host. This will allow you to both detect the data in transit and modify it as you see fit. Of course, any data you modify that is sent to your browser affects you and you alone. However, if it can turn off JavaScript client-side protection, this can be used to do other nefarious things like persistent XSS, which would normally not be allowed due to the client-side protections in place. Also, in the days of asynchronous JavaScript and XML, this tool can be incredibly powerful to detect and modify data in transit in both directions, while turning off any protection put in place by the client to avoid modification by the browser. This figure shows the request interception. This can also help remove lots of information that would otherwise leak to the target, including cookies, referrals, or other things that are either unnecessary or slow down the exploitation. Another useful feature is the ability to switch into hex mode. This is particularly useful when you are viewing pages in alternate encoding methods. This figure shows the response interception as a hex for IE7, and this figure shows the response interception as a hex for Firefox. Burp proxy is by far one of the most useful web application security tools in any manual security assessment. Hi there, welcome to my course. In this lecture you will learn about the XSS Discovery Toolkit Part 2, DOM Inspector. One of the most important characteristics of dynamic hypertext markup language and AJAX is that they both perform dynamic modifications on the web application HTML structure. This makes web applications a lot faster and thus more efficient because only parts of the web page are updated as compared to all of the content. Knowing about how the HTML structure changes is the first step when performing a security audit. This is when we use the DOM Inspector Firefox extension. Since 2003, the DOM Inspector is a default component of the Firefox browser. You can access the extension from Tools DOM Inspector. The figure shows the default screen of DOM Inspector. If you can't find DOM Inspector in your Tools menu, it is probably not enabled. In order to enable it, you need to download the latest Firefox installation executable and install it again. When you are asked about the type of setup, choose Custom. The Custom Setup window configuration dialog looks like that in the figure. Select the DOM Inspector checkbox if not selected and pass Next. You can continue with the rest of the installation using default settings. The DOM Inspector dialog box is divided into 4 main sections as shown in the figure. The top part contains information about the resource that is being inspected. The middle of the dialog is occupied by 2 inspection trees from where you can select the type of structure you want to explore: CSS, DOM, JavaScript object and so forth. The bottom of the dialog box contains the actual page that is under inspection. We use Gmail in this example. The middle part of the dialog box, where the inspection trees are located, is also the most interesting. You can navigate through the DOM structure by expanding and collapsing the tree on the left side, which then updates the content on the right side and allows you to narrow your search. The left and right side have several views that you can choose depending on the purpose of your inspection. If you are a graphic designer, you might be interested in inspecting the various CSS properties, or if you are a web developer or security researcher, you might be interested in examining the actual DOM JavaScript representation. Each of the inspection trees has a button to allow you to choose between the different views, as shown in the figure. By switching between different views, you can explore the HTML structure of the application that you are testing in the most precise manner. You don't have to examine messy HTML, CSS or JavaScript code. If you select a node from the DOM inspector, you can copy and paste it to a different place. You can read the XML code that composes the node or highlight the element on the HTML page. All of these operations are performed from DOM inspector contextual menus. The figure shows the selected node contextual menu in action. It will take a while to learn how to navigate through the DOM structure via the DOM inspector, but it is well worth the time. It is particularly important to know how to explore a JavaScript DOM structure. This is because developers often attack custom events, methods and variables to these elements, which can reveal how the application works. With DOM Inspector, we can look into how function calls are structured and the event flow of the application that we are testing. This figure illustrates several DOM methods that are available on one of the inner iframes of Gmail. All of the functions visible on the figure are standard for most DOM representations. If this iframe is important for the application workflow, we can replace some of these functions with our own and essentially hack into Gmail internal structure. Hi there, welcome to my course. In this lecture, you will learn about XSS Theory. Non-persistent. Consider that a hacker wants to XSS a user on the http://victim/ a popular e-commerce website. First, the hacker needs to identify an XSS vulnerability on http://victim/. Then construct a specially crafted uniform resource locator. To do so, the hacker combs the website for any functionality where client supplied data can be sent to the web server and then echoed back to the screen. One of the most common vectors for this is via a search box. This figure displays a common website shopping cart. XSS vulnerabilities frequently occur in form search fields all over the web. By entering testing for XSS into the search field, the response page echoes the user supplied text, as illustrated in the figure. Below the figure is the new URL with the query string containing the testing plus for plus XSS value of the p parameter. This URL value can be changed on the fly, even to include HTML or JavaScript content. This figure illustrates what happens when the original search term is replaced with the following HTML or JavaScript code. This is the code. The resulting web page executes a harmless alert dialog box as instructed by the submitted code that is now part of the web page. Pre-demonstrated that JavaScript has entered into the http://victim/context and executed. This figure illustrates the HTML source code of the web page linked with the new HTML or JavaScript code. At this point, the hacker may continue to modify this specially crafted URL to include more sophisticated XSS attacks to exploit users. DOM-based. DOM-based is a unique form of XSS, used very similarly to non-persistent, but where the JavaScript malware payload does not need to be sent or echoed by the website to exploit a user. Consider our e-commerce website example, as shown in the figure, where a feature on the website is used to display sales promotions. The following URL queries the backend database for the information specified by the product_ID value and shown to the user. This is the figure. To make the user experience a bit more dynamic, the title value of the URLs can be updated on the fly to include different impulse by text. The value of the title is automatically written to the page using some resident JavaScript. This is where the problem is. In this scenario, the client-side JavaScript blindly trusts the data content in the URL and renders it to the screen. This trust can be leveraged to craft the following URL that contains some JavaScript malware on the end. This is the code. As before, this URL can be manipulated to src in additional JavaScript malware from any location on the web. What makes this style of XSS different is that the JavaScript malware payload does not get sent to the web server. as defined by request for comment. The fragment portion of the URL after the pound sign indicates to the web browser which point of the current document to jump to. Fragment data does not get sent to the web server and stays within the DOM. Hence the name DOM-based XSS. Hi there, welcome to my course. In this lecture you will learn about XSS Attack Methods, stealing search engine queries. SPI dynamic showed that attackers are able to build up the JavaScript or CSS history hack to uncover various search terms that a victim may have used. It might be helpful for them to know if a victim has searched for MySpace and the like. The way the hack works is by dynamically creating predictable search term URLs generated by popular search engines. For example, if we searched Google for XSS exploits or Jeremiah Grossman, the browser's location bar would appear as shown in the figure. Search term URLs are easy enough to create in the thousands. Combine this with the JavaScript or CSS history hack and search history is exposed. Essentially, the attacker generates a long list of links in the DOM, visibly or invisibly, and checks the computed color of the link. If the link is blue, the victim searched for that term. If it is purple, they have not. The results of this method can be spotty, but it does not cost the attacker anything, so it could be a worthwhile procedure. SPI Dynamics set up an online proof of concept to show the results in action. JavaScript console error login checker. People are frequently and persistently logged into popular websites. Knowing which websites can also be extremely helpful to improving the success rate of CSRF or exponential XSS attacks, as well as other nefarious information gathering activities. The technique uses a similar method to JavaScript port scanning by matching errors from the JavaScript console. Many websites requiring login have URLs that return different HTML content depending on if you logged in or not. For instance, the account manager web page can only be accessed if you are properly authenticated. If these URLs are dynamically loaded into a angle bracket script src equal angle bracket close tag, They will cause the JS console to error differently because the response is HTML, not JS. The type of error and line number can be pattern matched. This is the figure. Using Gmail as an example, angle bracket script src equal double quote close http mail.google.com/mail/ angle bracket close as shown in the figure. Displays a screenshot of the JavaScript console when a request is forced in this manner by a logged in user. Notice the different error message and line number of the figure where the same request is made by a user who is not logged in. An attacker can easily conduct this research ahead of time when planning highly targeted and intelligent attacks. Not to mention, it is also useful to those looking for additional profiling for marketing opportunities. The comments within the code below designed to work in Mozilla Firefox. At a high level, certain URLs from popular websites have been selected because they respond with two different web pages depending on if the user is logged in. These URLs are placed in script src DOM object in order to get the JavaScript console to error, where they can be captured and analyzed. Like a signature, depending on the JavaScript console error message and line number, it can be determined if the user is logged in or not. Hi there, welcome to my course. In this lecture you will learn about advanced XSS attack vectors. Expect vulnerability. Thiago Gianninotti discovered a vulnerability in Apache HTTP server that took advantage of a minor hole in how Apache displays errors. This exploit was so widespread that nearly every instance of Apache on the web was vulnerable for some duration of time. Although this was discovered in August 2006, it is not uncommon to find old web servers that are still vulnerable to this exploit. Here is an example of what the headers would look like to create the attack. This is the example. When the web server receives the erroneous information, it outputs an error. The error is actually read by the browser as a valid HTML outputted page. Due to this, in IE, you can actually cause server-level XSS exploits, which will make the URL, once the page stops loading, look exactly correct, but it will be under the attacker's control. Here is the output. This is the output. Now the real question is, how do you get someone to forget a header? There is a way to do this in Flash, and a prototype example of this is located at http://aj.seekers.org/experts.swf. Here is the uses. This is the figure. This figure shows the example of an exception exploit in BeyondSecurity.com. Because Flash has the ability to spoof HTTP headers, the attacker has the ability to force the user through redirection to visit the page while sending the malicious header. In this way, the attacker can inject XSS into any vulnerable instance of the web server. This primarily affects versions of Apache prior to 1.3.35, 2.0.58 and 2.2.2. However, it may affect other variants. This is a good lesson though. The attacker can leverage any American Standard Code for information interchange output as long as it does not break the HTTP standard in a way that causes the page to fail to load. Hacking JSON. JavaScript object notation is a simple text-based data transfer format that is easy to use and entirely compatible with JavaScript interpreters. JSON is largely used in asynchronous JavaScript and XML as a simple, lightweight alternative to extensible markup language. JSON follows the syntax of JavaScript to define structured data. For example, arrays are represented like this. This is the example. Notice that this is also the syntax for declaring arrays in JavaScript. Apart from arrays, JSON can also serialize objects. For example, this is the example. The serialized object contains the parameters name and cities. The name parameter is a string, while the cities parameter is an array of strings. Although so far we showed the two most common forms of JSON, it is worth mentioning that all of the basic JavaScript types are also valid JSON representation. For example, a JSON number is serialized like this: 1, 2, 3, 4. JSON strings are serialized as shown in the figure, or this as shown in the slide. In general, every expression that is valid in JavaScript is also valid in JSON.